All right, everyone, Mr. Newman here. We're going to do a few word problems. So first of all, I just want you to notice and remember slope-intercept form, standard form, and point-slope form. The one we're going to be using today is slope-intercept form. But instead of y equals, we're going to see f of x equals in function form, which is just fine because you guys know y and f of x in this class are interchangeable. So first thing we need to do is we need to state whether the function is discrete or continuous based on the situation. The way you do this is you ask the question, does it make sense that the in-between numbers are in the domain? Now, what do I mean by in-between numbers? Well, let's look at a few examples, and I'll show you what I mean by that. Here, Sal opens a new video store and pays the film studio $2 for each DVD he buys from them. The amount Sal pays is given by f of x equals 2x, where x is the number of DVDs purchased. The thing we need to focus in on is that domain there. X is the number of DVDs purchased. Sal could buy one DVD. He could buy 2 DVDs, 3 DVDs, 4 DVDs, 5 DVDs, and so on, okay? He could buy any number of DVDs, but can he buy 1.5 DVDs? You see, that's what I mean by the in-between number. 1.5 is in between the numbers that I listed there. 1.5 DVDs doesn't make sense. So the answer is no, he cannot buy 1.5 DVDs, and that means that our domain and our range are discrete. That means only certain numbers. It doesn't necessarily just mean whole numbers, but only certain numbers, not the in-between numbers, just certain numbers, okay? Those numbers may keep on going forever, like he could buy 100 DVDs, 1,000, 1,000,000 DVDs. That could keep getting bigger and bigger, but he can't buy the in-between numbers. Now, Elsa rents a booth in her grandfather's mall to open an ice cream stand. She pays $1 to her grandfather for each hour of operation. The amount Elsa pays each hour is given by f of x equals x, where x is the number of hours her booth is open. Here, the domain is the number of hours her booth is open. So she could have her booth open 1 hour. That makes sense. She could have it open 2 hours instead. She could have it open 3 hours or 4 hours or 5 hours. But the question we want to ask is, can she have it open for an in-between number? For example, 1.5 hours. Well, could she? The answer is yes, she could. Well, what about like 2/3 of an hour? Could she have it open 2/3 of an hour? That's another in between. I think it's 40 minutes, but yeah, she could have it open for 2/3 of an hour. Sure. So that means the domain here is continuous. In other words, when we're graphing it, we want to connect all the dots because those lines in between the dots represent that there are dots between the dots. Points between the points, and we want to include all of those. That's why we draw a line on a graph. All right, so graph each function situation and give the domain and the range. First of all, we said that this function situation from the front, this is discrete. So when we get to graphing it, we don't want to connect the dots. But we'll remember that later. So x is the number of DVDs purchased. I'm going to put DVDs in the x column. We could have 0, 1, 2, 3, 4, or 5 DVDs or more, but I'm just going to do those points. We're going to use the function and get our outputs. We did this before, so I'm not going to take too much time on this. 2 times 0 is 0, so we plug in 0. F of 1 is 2 times 1, so we get 2. And we get 4 and 6 and 8 and 10. Now, some important things when graphing these. Make sure you label your axes. So that means both put what it represents, like DVDs, or number of DVDs, and put your numbers, 0, 1, 2, 3, 4, 5, and 6. On the y-axis, I need to figure that out. The amount Sal pays is given by f of x. That means that y, or f of x, is how much money that Sal pays. So money is paid, and 0, 2, 1, 2, 3, 4, 5, all the way up to 10, because I need to include 10 on there. The points then are 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, all the way up to 5, 10. And you guys notice the pattern. I go right 1 up 2, right 1 up 2, right 1 up 2. That actually is related to the slope. The rise over run is 2 divided by 1, which is 2. So if that slope is 2, I'm going to keep going up, right 1 up 2. I can even plot the next point even though it's not in my table, which is perfectly fine. And in fact, I probably should plot it because I'm not going to connect these dots, but I want to graph all the points possible on this table, or on this graph. So because it's discrete, we do not connect the dots. I can't have 1.5 DVDs, and if I connect the dots, I'm saying, yeah, you can have 1.5 DVDs. No. Now, what's the domain? Well, the domain, if it's discrete, we just need to list them. 0, 1, 2, 3, 4. There's a problem. We can't list them all, so you do this thing where you put ... okay? Or, AKA, you can say the whole numbers, because 0, 1, 2, 3, 4, all going on, those are, we call that the whole numbers. For the output, the range, those are 0, 2, 4, 6, 8, and so on, also known as the even numbers. Now we need to be a little careful there. I should probably say like even numbers greater than 0 or something like that, greater than or equal to 0, because -2 is technically even, and you can't have -2 money out of this situation. All right, so we're done with that one. This last one is the second one. First thing we need to say is it is continuous. And X is the number of hours her booth is open. So I'm going to write down hours right above the X value there. The hours we decided they could be open was 0, 1, 2, 3, 4, and 5, and so on. But it could also have fractions of hours. When we get there, because it's continuous, we're going to need to connect the dots. That doesn't mean that we need to put that in the table necessarily, but know that you could put it in the table. F of X is X. This is a bizarre function. We actually call this the identity function because whatever you plug in is what you get out. So the output is Y. Whatever you plug in, if you plug in 1, you get out 1 because it's just X. F of X equals X. So it's a little silly, but that happens sometimes. And the reason for that is because she pays $1 to her grandfather for each hour of operation. And so she's paying exactly however many hours she's staying. So amount paid, dollars, money paid, or pays money paid, she pays, that will be on the y-axis. Hours on the x, let's label those. Money paid on the y, 0 through 5, and let's plot the point, 0, 0, 1, 1, 2, 2, 3, 3, and so on. We don't need to plot all these points because when you draw a line, you're actually plotting an infinite number of points. You're plotting all the points. Make sure you have an arrow at the top right, not necessarily at the bottom left because you can't have negative hours and negative money there, but the number, she does keep on going up and to the right, and continuous means connect the dots. That's why I drew that line. Let me show you real quick. If we ask the question, could she have 1.5 hours? Now I see, if I follow that dot, that dashed line directly up, yes, 1.5 is on the function. It's a part of the domain, and so that makes sense because she could have 1.5 hours. Domain is everything greater than or equal to 0, so I can just write that. If you prefer the other notation, you can say 0. We call the interval notation. It looks like that. And range is y is greater than or equal to 0. Again, interval notation there looks like that. Thank you very much for watching.